Let's talk a little bit more about ThumbPass. So what I realize actually now is just this thing is previewed on. Select all this visual arrays, all these components here. Everybody is following. Like if you couldn't do it, that's fine. We will do it together, and then you will have another one to do. So select all this, right click, and preview off. Right click, preview off. And don't right click on one of the components. It will just preview off for that component. So when you select, just right click somewhere on the canvas. So let me go and select my weather file, set one file. Where should I go this time? NREL. Okay, so I have the weather data. I disconnect this for now. So first of all, I want to see what I have. I right click here and I preview on. I turn on the preview for the SunPass. There should be a SunPass somewhere. I right click, I click the middle click and then I do zoom. And for some reason it doesn't work here, which it should. So now I can see my SunPass. One thing about let's talk about SunPass. So this is an annual SunPass I have here, which basically means these lines that I draw, so every line is for a single hour, and these lines are 21st of different months. If you want, there is here an input for daily or annual SunPath. When you set this thing to true, I think, which is by default set to true, it shows you the annual. But if you set this thing to false, if you bring a Boolean toggle, let's see if it crashes, because it crashed for you, Rami, right? Okay, it doesn't. So this is a daily SunPass. This is a 21st of whatever, we should be able to read it here, 21st of September. And these are the sun positions at 21st of September. And I already showed you how you do it, right? Like how you understand which one is what. You have a sun position information. So I can use this information. I can bring tag 3D. And then I can do some positions for the location and the information here. And then I can't see anything because they're so small. So I just change the scale. And here we go. And then I showed you how you can basically project this thing to camera. So we are not going to do that. So now, watch here. If I change the month, I zoom out a little bit. So it goes for every month, it goes to that 21st of that month. You see like suns goes all the way up and then it comes down. December. And it goes like, it's not January, February, March, April, May, right? I mean, that's something that I think like all the designers want the SunPass actually to dance, but it doesn't. So it doesn't help you that much for randomness. So it just goes all the way up, it comes down, right? So what we were seeing before, if I disconnect this, was all these days, like all these days, 21st of all this month, and then these lines are presenting a single hour. This represents like hour 1, right? This one is hour 2, where the sun is at hour 2 for every month. So this is how you read the SunPass, first of all. Then what I asked you to do was to generate the sun positions for all the month. So right now I have only a single month because the input for the month is only a single number, which is 10. So what we need is a series of numbers. What you can do is basically you can bring a panel. You start typing if you want to say 1, 2, 3, 4, 5, 6, 7, and maybe up to 12 is not that painful to type. But if you have like 100 numbers, you don't want to do that. So there's a component for that called series. This component that generates a series. What series does, again, I bring a panel, I connect it here. It generates a series of numbers from the start which is 0 in this case, for each step of 1, and for 10 number values, right? 10 counts. So now I want to generate numbers from 1 to 24. So I put, sorry, for the month I want to generate from 1 to 12. So for the start, I wanted this thing to be 1. I just right click and press 1 here. It's totally fine if you want to do 1 and then connect 1 here. Just look the output, check the output, it will stay the same. Or you want to bring a slider and do 1. No difference. So delete, delete. And then n is 1. I'm fine with that because I want it for every month. The only thing I want here is I want it for 12 months. So it gives me numbers from 1 to 12. So now if I input this as the month instead of this 10, boom, I get it for all the months. Is it clear what happened? So the component goes for every hour that I ask for, and every month that I ask for, and every day that I ask for. If I just put a single hour, like 10, you will see it will show me the sum positions for this hour during the year for all the months. It's up to you, based on your problem, what do you want to get out of it. So for now, we decided to generate it for 21st of each month. And then the next thing that I asked you to do was to put the data that we need, because we want to decide to design a shading, right? So we want temperature and radiation. You go here, you find variable of temperature, you just connect it here to annual hourly data, and this one, now you get the temperature values mapped, and then you select global horizontal radiation. You have this thing mapped, and I zoom out, and I see I'll have all this data on top of the SUMPASS. So now if I write my conditional statement, I should be fine, right? And I have my conditional statement up here. What was this? So I just copy paste it. I mean, you can type it definitely. And I connect this thing here, and let's see how many hours we get. Here we go. Up here for NREL. So it's kind of 3 months. So you know, like now you can go and say, okay, this is the months of August, June, July, and check the average. See, okay, during the afternoon it's kind of cooler than 18. You know, just it's more than just a graph. Really, like it can help you to understand what's happening in that area. Just looking to the SUMPASS and having the data connected. At the same time, I can go and see, is this happened because of I said something that I could be like 100% wrong, and nobody told me I'm wrong. I take it as because you guys are polite. But what I said, this is how easy you can read something wrong. I said A bigger than 18 and B bigger than 240. Maybe it's because of radiation and it's not because of temperature, right? Because I'm calling the values for both of these graphs, and I say A and B. So it will show me the situation when the temperature is more than 80. Oh, I'm wrong. So it should satisfy both. I was right. Okay. Confused? Sorry. Hopefully I didn't get you guys confused. Yeah, so it satisfies both. So it's here we don't get, like, we get less radiation than 240 and the temperature is less than 18. This is and, is not or. So now we have some positions, we can design a shading. If you look here, I have a sample glazing for you. Turn the preview on. There's a glazing somewhere. You see this? It's like next to your SUMPASS. Here. And I internalized this glazing. So it was here. We don't need to move your SUMPASS here because you're using vector. That's why vector is useful to design a shading. What we want to do is we want to design a shading for this sample glazing. But just for the sake of presentation, if you want to do a presentation to someone or yourself, you want to move this SUMPASS to be in the center of this sample glazing. How you do that is Do you know what to use to get the center? You should remember. We used it last time. Okay, that's one way. But like I'm saying, like just use this geometry to find the center. Don't. I don't want you to draw the point in Rhino. I want to do something with this geometry to find the center. Area. So area component returns center. So if I do area, it will return the center point of this component to me, right? And then I don't want it to be here. I want it to be projected to XY. So there is a component project. Just if you type project, there is a project to plane. Project. This one, the second one. It will project an object to a plane, and the plane by default is XY. So just connect the center to this geometry, and you can see this point. What is the question? Because you didn't turn off this, right? Did you turn off the preview of this? Right click and preview off this. Is it fine? No? Let me help you for a second. So now go ahead and try to move the sum path here to center of this. So you have this point. Here's the point component. Here's your sum path component. Find a way to move this sum path using this point while I'm helping your friend. But what you need to do is to use the geometry here, which is the new point, and connect it to the center point. So it will move the sum path here. So I can hear probably multiple people watching this will say this is not the best way to use Grasshopper. In Grasshopper, you want always to have the data flow coming from left to right, right? And you want to keep your component similar to. So you usually don't do something like this. I mean, it doesn't change what really happens in the component, but it doesn't look right. So I just moved these things here. So now you see like my sum path is located in the right place, and this one has nothing, right? So now it comes to the point of like, okay, I want to do presentation and I don't want to have this one show up, right? But I still want the data to be connected. Hopefully I'm not going to lose you here, but oh, I forget to put this thing. Hopefully they could hear me. But how you can do it, if you check the outputs of these components, they're all branched in two different branches. You see it's 0 and 1, the outputs. So the outputs of sum path position is 0 and 1. 0 represents the first sum path, and 1 represents the second sum path. To do that, what you have to do is you have to preview off this, preview off your sum path, and then use a component called bang. Bang. Just type bang. It's explode tree. So it will bang the data tree. Basically, it will output every single branch in a different output. Or you can select. I like bang because I think it's really simple to work with. But if you want, you can also use select branch. So there is a select branch component which is here. If you go in sets, tree branch. Okay, it's not select. It's tree branch. You can do the same thing. You can connect a tree here, but I assume many of you don't know what's the tree. So you can connect a tree and you can pass 0 here. So it will give you the first sum pass. But for now, just let's use bang because it's easier. I select bang and then go zoom in and press minus here. Remove the 1. It will give you a warning, but don't listen to it. So what I did now, like I connected this output, which was my sum positions. You see it only gives me the outputs for this sum pass and not the second one, because I'm only visualizing the branch 0. So I can do the same thing with everything, like sum pass mesh. I can do the same thing here. I can do the curves here, and I'm zooming to the wrong place. So now I get like what I want out of the sum pass, and the other one doesn't show everything, but it just still shows this one because the data is connected, right? So I can do the same bank thing. I just copy paste the bank. I connect the locations. So all I did, there was 2 branches coming out of my sum pass. I only wanted the first branch, and I use bank to do that. And as I showed, there are different ways to do it. It's not only bank. You zoom in, and yours was like this. You just press minus. So we did bang it. We did put the sum pass in the right position. Everything looks good. Everyone is following. The second bang. I just copy pasted. So Control C, Control V, and then I connected the sum positions, because for this one, for the test tag, I needed, like, for these ones I don't really care because I only want to preview. So I just connected everything here. I preview off this, and I connected everything here. And I'm only selecting one branch, so it only visualizes that branch. But for these ones, because I want to use them later, so I want the data to be separated. You know what I'm talking about? Like, the output of this is now like bunch of stuff. It's a mess. But here I want to have the clean flow of data. Now I did this, I did that. There is a component here which is the shading designer, design shading. There are minor bugs still in this component, but it works fine for simple cases. Let's talk about this component. It can do so much, but right now I don't think we can cover everything because we won't have any time to run any analysis then. So what you need to design your shading is basically the surface that you want to design shading for, and then the vectors that you want to protect from. Does it make sense? This is all you need. So I have my vectors, and I didn't go to read all the data that we mentioned. We just filtered it here, so it gave me the vector. So all I need is to connect my glazing. Wherever your glazing is, just drag that and connect it to the input of glazing surface. So wherever your glazing is, sample glazing is, get this thing and connect it here. And boom. It should give you so many surfaces. For each single vector that you have, it gives you a single surface. And then you see they're colored. The colors represent how much radiation you're blocking with every single vector. So this is, the data is connected. So what I did is basically I used the output, which is shading surfaces, and from here I have the radiation data coming out of my selected hourly data, right? And then similar to what I showed you last time, I'm generating colors based on these values, and I put them on my shadings. What is the use of this? I can just watch and say, oh my goodness, this shading is so long, but it's not the most critical part of my shading, right? Because it doesn't block the highest values. Or I can zoom out a little bit and I say, okay, if I want to be really only blocking the critical values, this is the area I really want to block. Can you see the value of having the data connected to the geometry all the way? And this is really critical that you guys understand the data. You will have these examples, and this week until next week you have to go and do it yourself, and probably you will make some mistakes. How to get the data and geometries passed together. I'm taking care of data trees in many places and we don't talk about it, which probably you won't. and you will get like all the shadings blue. Sometimes you get everything red, you know. Then you play with it until you figure it out. But just speaking of SUMPASS, if you go back, there is an input here for merge vectors. And what's the use of that thing is like you have all these surfaces. What if you say like, okay, I want to just give me a single shading for all of that. You say merge vectors and it gives you a single geometry. It basically merges all that surfaces. For some of you, it may not merge the surface, which means the merging fails. And if the merging fails, it will tell you in the README that the merging failed, but you have the surfaces, so merge it yourself. Right? So because like merging and all that stuff in Grasshopper could be tricky based on the tolerance number and all that thing. So maybe sometimes it fails. So I want to give you the surface as the output so you can do it yourself in Grasshopper. One more thing that you can do is, okay, this was cool kind of, but you know what? I don't want to have a horizontal shading and I don't want to have one. Let's first talk about that. So you have an input here for the number of shading and it was 1. You can start changing this, 2, 3, you see? So it will design the shading for you based on the number of shadings that you want. And as you see now, it has started to give me the wrong colors. Because now the data doesn't follow. This is not something that I want to solve here, but I'm just showing you it can be really wrong. Does it make sense? I'm changing the number of shadings. Instead of changing the number of shadings, you can change the distance between shadings. That's possible too. But the last thing I want to show you about shading is, what if you want to have it on an optional surface, what I call it. So, you know, you want to do a design and you say, you know what, I don't want to have horizontal shading. I have a surface already designed, and calculate the shading for me on this surface. So this is this optional curved surface. Just right click and preview on, so you should be able to see it. So now if you connect this one to the optional shading surface here, it will redesign the shading, but it will design it on this surface for you, right? So don't get confused. There are multiple things here. So I selected the optional curved shading. And it happens like you have a wavy surface that you want really to work for you as the shading, and you want to cut that surface based on the sum vector. This gives you that ability. So what I did, I just connected the optional curved shadings to optional shading surface. And now you see my shading surface is this, based on my vectors. The other thing that you can do is, like, this surface shouldn't be really only a simple planar surface. It could be non-planar. So again, what I do here, I get rid of this optional shade surface. I disconnect this. So it gives me the normal shading. I put this thing to number 1. So the number of shadings are going to be 1. I set the merge vectors to false because I want to see different shadings that I get for every single vector. And then I go ahead and I connect this curved surface. If you preview off this one, if you preview off optional curve shading, right? Everybody follows. If you preview off this and preview on this, you will see there is a surface, like a curved surface in a curved building. So you can connect this one as a glazing surface. Instead of the surface that we had before, which was this surface, I can just connect the new surface, which is a curved surface. It will do the same. You see, now it's designed the shadings for me, but it's for a curved surface. Make sense, everyone? What? You got a red box? Sometimes, like I said, this is still a little bit buggy. So maybe based on your vector, if you want, just save that file and send it to me. I can take a look. But it usually works. So if you change your, sometimes you have to remove some of the vectors, all that stuff. Any questions? Visual arrays. So if you connect the surface that you're designing shading for, like whatever is the input of your glazing surface, connect it to this B input here. Whatever you're using to whatever you're using to for generating the shading, connect it to the B input of this, and then go and turn on the preview. So now it shows you all the sun vectors that you get, sun lines. And now you can see how the shading is actually designed. So it basically solves all these intersections for you. And if you have a sun coming from backward, that's why your shading comes from backward. You know, so there are different ways to solve this. Like you can check the vectors and just get rid of the vectors which are behind your surface, all that stuff, which is not something that the component takes care of right now. And you should do it, but like probably for the next versions, we will take care of that. So now I go like select a simpler, connect a simpler surface here and connect a simpler surface here. So hopefully you can see what's happening. So you have these surfaces coming in, and every single shading is basically designed based on this vector. It comes from the bottom of the window, it finds the intersection, and it calculates the shading. And believe it or not, I was thinking this should be your homework for the last class. So can you see the input for optional plane? Optional planes. Similar to what I did, and I did an optional shading surface, you can generate a plane and put it inside. So let's do it for you. So do you remember that I had the center point of my, so the first thing I do, I go preview off this. And preview off my SunPass. I'll bang things. Preview off. Let's just watch this. Okay, so the question is, we have the shading up here. What if she wants to bring it down here? What if you want to design a light shelf? Right, this kind of stuff. So for now, I just use the center point to bring it in the middle, but definitely there are ways, as I showed you, to find the right place for the plane. So I use this point to generate a plane. How to generate the plane is, if I type plane, there is a plane by normal component here, plane normal. So what do you need here to generate a plane is the origin of the plane and the vector. And as you can see, the default vector is 0, 0, 1, which is the z vector, so it's fine. This is what I need. So I just use the center point here. I connect it as the origin. So it gives me this plane. Now if I use this plane and connect it to optional planes, it will design the shading on that plane. If you have multiple planes, it will be multiple. And why does it on both sides? I really don't know. Probably because the point is just exactly on the surface. It shouldn't. But now you can generate multiple plane, or you can start rotating the plane if you want to have a different angle, right? Or like it gets more interesting if you have something curved, right? Like this surface, and you want to design vertical shadings. So you can find the curve beneath here, and based on that, generate multiple planes. Do you want me to do that? Or is it something, I think we can go for the radiation analysis. So let me do that if it's interesting. So that's how I never get to the radiation analysis. That's just so normal. So I have this surface, right? I can find the wires. And then I want to find the one bottom here. The simple way that I showed you is to select it by item. Not the best way, but for now it works. So let's do it. I just do this, and I was lucky. The item 0 was exactly what I wanted. So this is this curve. How I know, like I can see this thing is green. Can you see it too? So I can just preview off this so you can see it better. So this is all the wires, right? If I preview off this too, this is the selected wire. Now I want to generate planes. There is a component that does that. If we got lucky, all the planes should be in the same direction. There kind of are. So what I did, do you remember the evaluate curve component that was giving you multiple point, or divide curve that was like, I can show you, that you could connect a curve and it was generating the points? So we used this component before. What it was doing, you connect a component, you connect a curve, and based on the number of divisions, it generates the points. This component does the same, similar thing, but this time it generates planes and not points. And now I have all these points, so I can connect these points to design the shadings for. So I just connect this thing, because this is the surface that I want the shading to be designed here. And then I connect my frames and I keep my fingers crossed. Here you go. So now it designed all these vertical shadings for me for every single curve that I have. And now you can see, for example, when you have a sun vector coming kind of perpendicular to your window, why you can't really block it, you know. Like this is a probably, hopefully we can talk about. Does it make sense? Okay. So this is how you can use all this. I mean, you can do way more. For example, if you want to understand which building is actually blocking your building as a vector, just instead of optional geometry, put that building in, and it shows you what part of the building is shading your building. Does it make sense? Because that's what the shading is. If you want, I can have an optional surface, which could be a horizontal surface. The optional surface could be my residential building next to me. It will design that one for you. And based on what's happening here, actually, this is how we are doing this sun fan. Where are they? Here. The solar fan and solar envelope. Solar fan is basically put a horizontal plane on top of your site and calculate the shadings, and then Boolean union all that shadings. It means the area that will be, the sun vectors will come in always in horizontal. This is more important than learning. You can easily figure out the components. You make mistakes like 10 times, 11th time it works. But it's important to understand what's